Hello, everybody. So we are going to kind of start with 5.3 and 5.4. I'm going to try to make one video about that in maybe 20 to 30 minutes. We'll see. Hopefully, I can squeeze it in. So this is 5.3. So what this is about? This is about some more identities. So kind of the rest of the chapter is about other kinds of identities that are kind of frequently used. We're not going to do all of them. What we just got through is fundamental. So those are like the most important. These are like next here. Like they're pretty important. They will be used, but maybe not quite as important as some of the other ones. Okay. But we have something like this. It's called sum identity for cosine. And it's a kind of a formula. So this involves the sum of, say, two different angles or two different numbers, if you want to think about it this way. So it's like cosine of A plus B. So cosine of A plus B. This is interestingly equal, and I'm not going to go into how it was discovered or whatnot. Don't have enough time in this video. I'm just going to give you the formula. So this formula ends up being cosine of A plus B is cosine A cosine B. And then, interestingly enough, if it's a plus, this ends up being a minus here. Cosine A cosine B minus sine A sine B is the sum identity for cosine. Okay. There's also a difference identity for cosine. And that identity is cosine of A minus B. That ends up being cosine A cosine B. And then just minus, it becomes a plus here, sine A sine B. Now, write those formulas down. Those are the two that we're going to use in 5.3. There's a couple from 5.4 that I'm going to go ahead and give you right now at the start before I even do any other problems. So kind of get the formulas that you need for these two sections. So this is called sum identity for cosine. This is difference identity for cosine. Those are the two that you need for cosine as far as sum and difference. Okay. So pause it if you need to write them down. Okay, going to look at some other ones. Now this is actually 5.4 formulas now. And the question is, well, what if I do sine? So if I do something like sine of A plus B, what does that turn out to be? So this one is sine of A cosine of B plus cosine of A sine of B. Now, do you really have to memorize these? Probably not these particular ones, although if you are taking calculus, it might not be a bad idea to. But the way I remember, if it's cosine, you go cosine sine, and the sine kind of changes sign. If it's the sine, if it's a sum identity for sine, this plus would be a plus here. And sine goes sine cos cosine. So I've found a way to memorize it over the years. Do you need to? Probably not if you've got it written down right now. But just know more an awareness to know that they exist, to be thinking about them, okay? Because they do come up from time to time in calculus. We will need them, okay? And if I do difference identity for sine of, say, A minus B, that is sine of A cosine of B. And this is a minus, it's going to be a minus still, cosine of A sine of B. So I am literally just giving you the formulas. Normally I would explain them a little more, but we're just going to give them to you, and I'm going to explain how we would use them. Okay. All right. So let's look at how we would use these. Why would we want to know these identities in the first place? So I want to look at, say, number 5, and this is in 5.3. We'll start on 5.3. So number 5. And this is a question like this. What is the cosine of 75 degrees? Okay. So before, you may have noticed that if you type in a cosine of an angle like 15 or 75, it actually spits out an exact value. That's a reason for that is because it's related to these sum and difference identities. So if I would want to find this, and I say find the exact value, and let's do without a calculator. I realize you're at home and you can kind of cheat before, if you were in class, you wouldn't be able to use a calculator, but really you should be able to do this without a calculator. If I want to find what the cosine of 75 degrees is, the way we would do it is think about it as the sum of two angles that we know, like 30 and 45. So it's like cosine of 30 degrees plus 45 degrees. Using our formula then, so kind of go back and look at the formulas you've written down throughout this to check that you're seeing where these are coming from. This cosine of 30 plus 45 is cosine of 30 degrees, cosine of 45 degrees. And then plus becomes a minus here, sine 30, sine 45. So I write it out like this. What's the cosine of 30 degrees? Well, that is going to be radical 3 over 2 we talked about. What's the cosine of 45? Well, that's our root 2 over 2. Sine of 30 degrees is a half. And sine of 45 is root 2 over 2. So if I think about what this is really just root 6. Root 3 times root 2 is root 6 over 4. Minus 1 times root 2 is root 2 over 2. So root 2 over 4. 2 times 2 is 4. And then I would just combine those because I got a common denominator, right? So this value is really just root 6 minus root 2 over 4. And that would be it. That's the exact value using a sum identity for cosine, which is what we wanted to do. Okay. Let's take a look at number 11 here. So if I was going to do that one, I would have cosine of 40 degrees, cosine of 50, minus sine 40, sine 50. So this one, you're kind of working backwards in a way. So I write up the relevant identity. It makes me think of cosine A, cosine B, minus sine A, sine B. It reminds me of this identity here. Cosine A plus B is cosine A, cosine B, minus sine A, sine B. You may notice that this expression that we have here is the exact same as this, only I have specific values for A and B. So we literally kind of work backwards. I know that A is, say, 40 and B is 50, so using this identity, this is equal to cosine of 40 degrees plus 50 degrees, right? That is the exact same with the identity. So that's just the cosine of 90 degrees. Do you remember what the cosine of 90 degrees is? Yeah. That was 0, right? Now, kind of another interesting note here. If you remember your cofunction identities, or sine 40 is cosine 50, and sine 50 is cosine 40. So this is really the same as this. I'm subtracting, I get 0, right? So I already could have got it with cofunction identities. So kind of interesting to see how everything's all tied in together anyway. But